Hello and greetings to everyone. In this video, we are going to see how to find the rank of a matrix using the row echelon form. Now, what is the rank of a matrix regarding the row echelon form? It is simply the number of non-zero rows in the row echelon form of the matrix. So, if we can put the matrix in its row echelon form, the number of non-zero rows in that form simply gives us the rank of the matrix. Let's begin with an example. Find the rank of the matrix A. Now, our matrix A has been given to us, but what is the row echelon form of the matrix A looking like? It is looking like this. The first row remains intact. Now we have a diagonal line here, and all the elements below the diagonal line should be 0, though the last element of the diagonal line can still be 0 depending on the form that has been given. So remember, every matrix has its way of writing it in the row echelon form, but generally we just need to begin with the first entry. We draw a line to link the diagonals, and all the entries below that diagonal line that has been drawn, we need to put them to be 0. So we have been given this matrix A. Now we can identify this as row 1 and this as row 2. Now since our row 1 is to remain intact, we need to now we see that our x1, right, is a certain element. It can be 0, it cannot be 0 depending on the form, like I said. Now this element, this entry -3 here must be 0. So we need to find a new row. We can call it row 2 prime, where this element here, this entry, we can still call it element, this entry here should be 0. So what do? We see that if we take 3 times the first row plus the second row, we are going to have this entry here to be 0. So doing that, we are going to see the first row remains intact. We have the entries 1 and -2. Now if I take 3 times the first, let's deal with the entries first. 3 times 1 is 3 plus -3 is 0. So here we have 0. 3 times -2 is -6 plus 6 is 0. So we have seen that our element x1 here has been reduced to 0. So by so doing, the rank of this matrix is simply the number of non-zero rows, which is equal to 1, because here we have only one non-zero row. This row here is 0 because all the entries are 0, but the first one is not 0 because not all the entries are 0, and even we don't have any entry which is 0. So for a non-zero row, or if we want to see a 0 row, then all the entries of that row should be 0. Then we are going to call that row a 0 row. If one of the entry is not 0, then it is not referred to as a 0 row. So in this case, we have identified just one row which is not 0, which is this row, and this row is 0. Hence the number of non-zero rows is equal to 1. But therefore we have the rank of the matrix to be equal to 1. Now let's look at another example. Find the rank of this matrix. Now this is the form. Remember, we begin with our first row remaining intact. If we draw a line like this, right, all the elements all the elements below this line should be 0. We are also going to have a certain element here, x2. It all depends on you. Now by so doing, here's our element. Here's our matrix A, our row 1, our row 2. Now we need our row 1 remains intact. Remember, our row 2, now we need a new row such that this element here is 0. Now this element here is a certain element, and this is a certain element, though they can still be 0. It all depends on the form, like we saw in this case. In this case, we saw that this x1 here finally was 0, though in a certain case it cannot be 0, but if it is not possible for it to be 0, we allow it like that. So why are we doing this? Is simply to find the number of non-zero rows, and then we determine the rank of the matrix. Now we want to make this entry to be 0. So what can we do to this matrix to make this entry to be 0? We simply take the first row minus 2 times the second row, because here we have 2 minus 2 and we are going to have 0. So by so doing, the first row remains intact. Now the second row, you have 2 minus 2 times 1, which is 2, which is 0. Now here we have 4 minus 2 times 2, which is 4, so you still get 0. Now we have 5 minus 2 times -2 becomes 5 plus 4, which is 9. Now there is no other way that we can make this guy here to be 0 and these other guys remain intact. Hence this is the row echelon form of our matrix A. By so doing, how many non-zero rows are there? There are 2 non-zero rows, because the second row is made up of 2 entries which are 0, but now there's a third entry which is not 0, so it is a non-zero row. Likewise the first row. Hence there are 2 non-zero rows of our row echelon form of the matrix A. Hence the rank of the matrix A is equal to 2, because it is equal to the number of non-zero rows in the row echelon form. So that was that for the video. If you don't know how to find the rank of a matrix using the determinant, I'm going to display the video on your screen. You can click on the video and you watch.